Hi there, Mr. Sutton here, bringing you the AB Calculus 5-2 Extra Practice Number 1 Solutions on Antiderivatives Part 2. For the antiderivative on this one, I'm basically just going to start by taking the antiderivative of e to the something, so that would be e to the whatever. But since the something in here, since this is an inner linear function that's not just going to have a derivative of 1, I have to actually divide by the derivative of this to offset the chain rule. So I'm going to divide by -6. Since I already have a 1/2 out in front, that's going to give me a -1/12 for my new coefficient. And then don't forget the plus c. To take the antiderivative of this expression, since I have this inner linear function, I'm going to start by just taking the antiderivative of cosine, which is going to be sine. I'm going to leave the 10x in there, but to offset the chain rule, I have to divide by the linear coefficient in here. So I'm going to have -5/10 out here, giving me -1/2. And if you were to actually take the derivative of all this, you would have, let's see, a positive 1/2 cosine of 10x times 10 would give you the 5 out here. And then don't forget the plus c, of course. To take this derivative, I'm first going to simplify this by expanding this binomial. So just using my little a squared plus 2ab plus b squared shortcut, squaring the first thing, this is going to be 16x to the 6th, and this is all inside one big antiderivative now. Next, I have to multiply these terms together and double it for my middle term. So let's see, that's going to be 12x to the 5th times 2, so minus 24x to the 5th. And then squaring the last thing, that's going to give me positive 9x to the 4th. All of that with a dx out there. So let me just go from left to right now and use my reverse power rule. For this first term, this bumps up to an exponent of 7. Dividing by that, we have 16/7 x to the 7th. For the next one, this bumps up to a 6. Dividing by that, we have -4 x to the 6th. And then this last one, we get a 5 for the new exponent, so this is going to be 9 divided by 5, x to the 5th, and plus c. To get anywhere on this problem, finding the antiderivative, I'm going to have to factor and cancel some things out. So my numerator, I can factor this with two things that multiply to -42 and add up to -1. We have x plus 6 and x minus 7 up there. And then these x plus 6's can cancel. And notice I've still got the integral hanging around here, the antiderivative. So I'm going to have antiderivative of x minus 7 dx. Now I can just use the reverse power rule. So this first one, I'm bumping this up to a 2 and dividing. So that's going to be 1/2 x squared minus reverse line rule here. This is going to be -7x and then plus c. To find the antiderivative of this rational expression, I can make my life a little bit easier if I simplified by dividing each of these things up here by x to the 7th. So going from left to right, and I'm going to put all this in a parentheses now with a dx outside, we have 8x to the 6th over x to the 7th. That's going to be 8x to the -1. And then this next one, this will be plus 3x to the -4 minus 60x to the -7. Now using the reverse power rule from left to right, this first exponent, well actually we can't use the reverse power rule here because that would give us a 0, and dividing by 0 is a bad idea. This is actually your ln antiderivative. This is going to be 8 times the ln of the absolute value of x. And then this next one is reverse power rule. So this bumps up to a -3. Dividing by that, we end up with just -1 x to the -3rd power. And for this next one, this will become a -6. Dividing by that, we get plus 10 x to the -6, and then plus c. To help us out on this antiderivative, we're going to start by using a trig identity. Instead of writing 10 over sine squared of x, I'm going to write 10 times the reciprocal of sine squared of x, which is cosecant squared of x. Now that I've rewritten it like this, I do know the antiderivative of cosecant squared. That's going to be negative cotan of x. We have a 10 along for a ride, so this is a -10 cotan of x plus c. For this antiderivative, since I have this inner linear function, I'm going to have to account for the chain rule when I take my antiderivative. So I'm going to start by doing the antiderivative of e to the x, which would be just e to the x. So I'm going to just leave that as e to the 9x plus 1. But now since this inner function is linear, I can offset the chain rule by dividing by the derivative of this stuff. So I'll divide by 9. Since I already have a 3 out here, 3 over 9 gives me a coefficient of 1 over 3. And then I have a plus c after that. In order to negotiate this antiderivative, I'm going to start by expanding this parentheses so that it's just one big polynomial that I can use the reverse power rule on. So using my a squared plus 2ab plus b squared shortcut, I'm going to square this first thing. That's going to be 900, and we'll have x to the 10th. Now I have to multiply these things together and double it. So let's see, 30 times 5 is 150. Double that, we get 300. We have x to the 9th, and we're negative, so negative 300 x to the 9th. And then squaring the last thing here, this is going to be plus 25 x to the 8th. Okay, let me just use reverse power rule from left to right now. This first exponent bumps up to 11, so we have 900 over 11, x to the 11th. Next, we have an exponent of 10, giving us, let's see, 300 over 10 is 30, so minus 30, x to the 10th. And then here, this is going to become exponent of 9. So this is plus 25 ninths, x to the 9th. And then we have a plus c. Before I actually try to take the antiderivative on this one, I'm going to rewrite it using a trig identity. So instead of writing 5 over cosine squared of x, I'm going to write 5 times secant squared of x, because secant squared is really just 1 over cosine squared. Now that I've done this, I know the antiderivative of secant squared, that's tan of x. We have a 5 along for the ride, so 5 tan of x, and then we have that plus c. For this antiderivative, I notice that I have this inner linear function that I have to deal with. So first, the antiderivative of just normal secant tan is going to be secant of something. So I'm just going to rewrite this as secant of 5x. But now to deal with this inner linear function and the chain rule that it requires, I'm going to divide by the inner derivative. So I'm going to multiply by 1 over 5 outside here. And then I'll have my plus c over here. So if you actually take the derivative to check this, you're going to have 1/5 times secant of 5x tan of 5x times a tail of 5 using the chain rule, which would cancel this out and give us what we started with inside the integral. To take the antiderivative here, I'm going to start with my basic e to the x antiderivative, which is going to be e to the x. So I'm going to just write e to the negative 4x. But now I have to deal with the fact that this is not just x in here. It's a linear function, but it's not just x. So to offset the chain rule that I would get if I took the derivative of this thing, I'm going to have to divide by the negative 4 inside here. So this is going to be negative 1/4 outside, and then I'll have a plus c on the other end here. On this problem, I'm trying to take the antiderivative of 10 over the square root of 8x minus 4x squared. So this is one of those problems where very few people are going to get this on the first try. It's more of one of those where you see, when you see how it's done, you're like, oh, that's what I needed to do. And then you sort of file that away in your bag of tricks for the next time you see something like this. So one thing we're going to do in the beginning is, inside this radical, I'm actually going to factor out a 4 from both of these terms. Why? Well, we don't really know in advance, but I guess the short answer for now is because it's going to work down the road. So if I take a 4 out of here, I've got 4 and then 2x minus x squared. Now the nice thing about taking out a 4 is that since I'm square rooting a product, I can square root each factor individually, which means I can simplify this, basically square root the 4 and get it outside here as a 2. And I can do a little bit more at this point. For example, 10 over 2, I can reduce that to 5, which I'm going to because why not? But you might be wondering, well, what am I supposed to do with this stuff inside here? And this is, at this point, we're actually going to complete the square in order to get this as something minus something squared. So to do that, this is a little bit tricky. I'm going to have another constant inside here to go with the 2x and the negative x squared. I'd like to have a 1 in here. At some point, I'd like to be able to factor the stuff inside here as x minus 1 quantity squared or x plus 1 quantity squared, one of those. To do that, I have to have a 1 to go with the 2x and the x squared. But I can't just put a 1 in there for free. So what I'm going to do, and this is really sneaky, I'm going to add and subtract a 1 at the same time. So check this out. 10 over 2 reduces to 5, and inside I'm going to have 1 minus 1 plus all the stuff that was already there. Now just verify that this is legal. If I add 1 and subtract 1 at the same time, I have not changed the value of anything. But here's what I have done. These three terms here, I can now factor a negative 1 out of these last three terms, leaving me with positive x squared minus 2x plus 1 inside a big old parentheses. Now the reason that's nice is because if we factor this right here, two things that multiply to positive 1 and add up to negative 2, well, that's going to be x minus 1 and x minus 1, or just x minus 1 squared. And at this point, you might be thinking, this looks like the format of one of my arc function derivatives. And it is. This is basically arc sine, but instead of minus x squared, we have minus x minus 1 squared. So we can turn this into now 5 times the sine inverse of x minus 1. Don't forget the plus c, of course. So that's going to be answer choice. Got to be careful here because these are very similar. C and D are very similar, but we need answer choice C for this exact match. For this problem, we want to know which of these expressions is equivalent to what we have up here. Now, if you haven't seen definite integrals before, that's antiderivatives that have the little numbers on the antiderivative symbol. Don't worry about it for now because all the answer choices have a 2 and a 3, so you don't need to worry about those changing at this point. What we are going to do, though, is rewrite this so that it looks like one of these. And this is actually not so bad. All you have to do is just divide everything in the numerator by this x cubed in the denominator. So just going from left to right, we've got 5x squared plus this will be 4x, and this will be, let's see, 3x to the negative 1. 2 minus 3 is negative 1. And then finally we have 2 over x cubed, which is really 2x to the negative 3. Don't forget we still have a dx out there. And does this match anything we see over here? Let's see here. The exponent is wrong on this one. This one has also got the wrong exponent. Choice C is looking good so far. And choice D has a bunch of wrong exponents. So we're going with choice C.